Welcome back to day 9 of our Python Mastery series. Yesterday, we mastered comparison operators. Today, we take those comparisons and give them a brain. We're covering logical operators, and, or, and not. These are the building blocks of complex decision-making in your code. Think of logical operators like electrical circuits. They allow us to check multiple conditions at once to see if the overall logic is true or false. Let's start with AND. The AND operator is strict. It only returns true if both sides are true. If even one side is false, the whole thing fails. Here is the truth table for AND. True and true is true. But true and false? That's false. It's like a job requirement, you need a degree and experience. Example, if username equals admin and password equals 1234. If the user gets the password wrong, the AND operator ensures they don't get in. Watch what happens in the console when we run this. Python evaluates the left side first. This is a concept called short-circuiting which we will revisit. Next up is OR. Unlike AND, the OR operator is generous. It only needs one side to be true to return a true result. In the OR truth table, the only way to get a false is if everything is false. It's like a coffee shop, would you like TOR coffee? Either one makes the statement true. Let's code a discount checker. If student underscore card equals true or age greater than 60. If you meet either condition, you get the discount. Simple and flexible. Look at these two side by side. Use AND for restrictions and OR for options. Choosing the right one is the difference between a working app and a buggy one. Finally, we have NOT. This is the rebels operator. It simply flips the Boolean value. True becomes false, and false becomes true. If is underscore logged underscore in is false, then not is underscore logged underscore in is true. We use this often to check if a list is empty or if a toggle is turned off. Instead of saying if age is greater than or equal to 18, we can say if not age under 18. It makes our code read more like English. Now, what happens if we mix them? Python follows a specific order of operations, just like BODMAS in math. In logic, it's not first, then AND, then OR. Let's test your brain. In true or false and false, Python does the AND first. So it becomes true or false, which equals true. If you did it left to right, you'd get the wrong answer. To stay safe and make your code readable for others, always use parentheses. It forces the order you want and prevents syntax errors in logic. Let's talk about Python's efficiency, short-circuiting. If Python sees false and it stops immediately. It doesn't even look at the second half because the whole thing is already doomed. This is great for performance and preventing errors. For example, checking if a variable exists before checking its value in the same line. Time to build. We are going to create a secure Vault script that uses all three operators to grant access based on a PIN, a fingerprint scan, and an emergency lockout status. First, let's set up our variables, has underscore pin, has underscore fingerprint, and is underscore emergency underscore mode. Notice how we used the parentheses to group the requirements and the not to check the alarm status. This is real-world logic. Let's change is underscore emergency underscore mode to true and run it. See? Access denied. The code is working exactly as intended. The rule is, you need the PIN and the fingerprint, but only if we are not in emergency mode. Let's write that out. A common mistake beginners make is writing if x equals 1 or 2. In Python, this is always true because 2 is a truth-either value. You must write if x equals 1 or x equals 2. In Python, empty strings, zeros, and none are considered falsy. Everything else is usually truthy. This is why logical operators can be used on more than just booleans. Here's a pro tip, you can use OR to provide default values. If name is empty, it falls back to guessed. This is very common in web development. Today we learned, and for both, or for either, and not for opposites. We also touched on precedence and short-circuiting. Your task: create a script that checks if a year is a leap year using logical operators. Hint: a leap year is divisible by 4 and not divisible by 100 or divisible by 400. Great job finishing day 9. Tomorrow, we move into the world of loops. Don't forget to like, subscribe, and keep coding. I'm your instructor from Edulexis, and I'll see you in day 10.
Thank you for watching. Like if you learned something, share with your circle, and subscribe for more.